In this one we'll discuss about the break-even point. We'll discuss about fixed cost or the capital expenditure, long-term investment in the fixed asset like purchase of land, or construction of building, purchase of machine equipment. So these costs remain constant, like here in the 100 unit or 200 unit also the cost remains same. 500 unit whatever cost, 1000 unit also that cost is there. Okay, so this cost remain constant despite the volume of production, that is number of units, that is Q, number of units produced in a given duration. Okay, so that is the fixed cost. So we'll discuss, and then after there is another cost popularly, that is the variable cost. Okay, so variable cost at 500 unit, this is the variable cost. At the 1000 unit, this is the variable cost. Okay, so if the variable cost will calculate out for 500 unit, at 1000 unit, we'll see that it is exactly the double of that amount. Okay, so also at 100 units we'll say 100 unit, it is the 5 times of this one is at 500 unit. Okay, and this is the total revenue curve over here. Okay, and this is the total cost curve over here, and this point is we call as the break-even point, or where the total revenue equal to total cost, and total cost is the fixed cost, that is this fixed line over here. Okay, that is the irrespective of the number of units being produced, and variable cost is and the proportionately whatever is increased over there. Okay, and this point is that where we'll call that one as that total revenue equal to total cost. So on the x-axis every time I am taking the number of volume of production, and this one is the cost over here. So this region is the loss region for the company, and this point we are saying that at this point where the total revenue equal total cost, that is the break-even point. At this particular point we'll get that this is 500 plus some unit, that one becomes the break-even point for the company. So now after this one whatever we are getting, that is the profit. Okay, where that is the profit equal to profit, we can calculate in this way, profit equal to total revenue minus total cost. Okay, so can suppose assume that we have 4 projects, project A, project B, project C and project D. So in project A we are getting at Q1 unit, this is the here the break-even point over here. At this point over here, this is the break-even point. Okay, this is the break-even point. Over here the break-even point is at this point at and this is the D project. This is the means very early we are getting the break-even point over here. So this is preferred as compared to A, B, C, D. In this 4 condition we can say that only if the break-even point, the early recovery of the capital investment, we'll say that this is the point. Okay, now we'll say that different parameters over there when we'll say that it is not. So this is the one that just this is the total cost. Okay, total cost is moving in this line. Okay, and total revenue is moving in this line. Okay, this is at Q, that is Q1 I am getting the break-even point. Q2 my total revenue I am recovering more from the market, so this much of the profit I am getting over here at Q2 point. Okay, so I can say that in this way. Suppose the assumed one, I'll say that over here Q10, suppose I'll say the, so I can say that total revenue minus total cost, this much would be my profit over here. Okay, so this is the assumed profit, and now we'll see how the reality, what is happening over there. Okay, suppose a very high demand is there at a high rate. Okay, so here what we are saying that running because of the heavy demand, they are now running the plant in the double shift. Okay, so as a result of this, the total cost, it should be moving in this direction, the trend line should be moving in this line. Okay, but at this point what is happening is that the because of this particular thing, now there is a double shift over there. So as a result of this, the fixed cost is constant over there, but the variable cost is increasing proportionately. It is not increasing in this way, the total cost is not going. Okay, so new total cost is over here, total cost new is over here. So as a result of which, at this is the Q1, this is the Q2, and at Q3, this is the Q3, fixed cost is increasing all of a sudden this way. Okay, so as a result of which they are getting only profit of this much. Okay, instead of neither in this way nor in this way, but it is the profit is decreasing in this way. Okay, now again over here, commissioning new plant, they have expanded this one. Again at this Q4, what they are doing is that they are expanding this one, commissioning a new plant, because the demand is increasing. To in order to compensate that one, they are now increasing this one. So profit is decreasing, or we can say that the company is making, in other words, they are making the losses over here. But even though the company is making the losses, but we'll say that the company is in a growing stage, so the investors invest in this at that point of time. Okay, so shareholders invest in a at a growth stage, assuming that when the company is making the expansion, commissioning of new plant, okay, they are increasing over here, and here they are making the at Q4, they are increasing this fixed cost over here. Okay, fixed cost all of a sudden, instead of this graph is moving in this way. Okay, first they have increased the, at this one the graph is not moving in this direction, because they have extra demand, and in the shift wise they are working, so the variable cost is increasing. Now they have gone for the machinery implementation of new machinery, okay, in the same setup. Now again the variable cost is increasing in this way, okay, because of the fixed cost, and this one is the total cost increasing. At this Q4, all of a sudden they are planning that now the demand is increasing, and with this capacity we cannot continue, so they have commissioning a new plant over here. Okay, so at Q4 they are not making any profit over here, they are rather they are making the losses over here. So at Q5, combined break-even point of two plants. Okay, first plant they have received a break-even point over here. Okay, and the second plant, after commissioning of this one, they are now getting the break-even point over here, and that is at a Q5. At the Q6 they are making the profit of this much only. Again, two plants working at the double shift. Okay, two plants have been commissioned, okay, as a result of which they are making the profit. But again this graph is not moving in this way. Okay, rather they have started moving in this direction, because now two plants are working in the double shift, because the demand whatever was there, they are not able to fulfill that demand. Okay, so for that one, see, initially the graph was in this way, then the trend line was supposed to move in this way, trend line should move in this way. Okay, now it should move either in this way, but now it is moving in this way with only the limited profit of this thing. Okay, now so very high demand increasing at a high rate. Okay, so it will not be in a very smooth path like this. Fixed cost would be always be in this way, and then after the variable cost would be increasing in a very trend line manner. Rather it can move in it in many step costs are going to be involved over there, so we cannot predict the total cost in a very predictive line. Again, this is only the total cost factor only we are considering this way. Total revenue may also be affected. Total revenue, how it can be affected, like now the different other companies, they can come up with their competitive brand, and they may be offering at a lesser price. As a result of which, the price competition, you have to increase the selling price of that one. As a result of which, you can also, the total revenue, the demand would be high, but revenue will not be in a proportionate manner. So whenever we are going to select any project, like the example that we have seen over there in the ABCD4 one, we have taken this project A, project B, project C, and project D. Here different type of step cost has to be calculated, or the anticipation of that one step cost and step revenue. Okay, that one has also to be considered. Means instead of it is moving in this direction, it can move in a stepwise manner, like in this way, this way, this way, this way. Okay, so that step cost, how it is suddenly, this is only the example that we are saying, that it can vary. Okay, so even though we are predicting that this much of the revenue or the profit is expected at this particular point, but it may vary, but it may not be alluring at this point of time, and that this is D is better. But with a proper study, we can also analyze that even though the break-even point is, we are getting the break-even point at a later stage, but there may be some scopes are there in future, we will be getting a better return over here as compared to this one. It may go, the total cost may increase in this way, just like the example we have discussed. So here we may not get the profit, rather we may get the loss. So in the long run we have to calculate this one. So this is all about the value and return of the project with respect to break-even point. Thank you very much.